In this video, we will be reviewing 5 questions that deal with key concept 4, target 4B. Question number 1, or well, question number 6 in this case, is here. Question 7, 8, question 9, and question 10. So let's start with question number 6 here. We need to determine the interval where the height is decreasing. So the vertical axis here represents height. So we want to figure out when these numbers are decreasing. So if we follow the graph right here, all these y values are increasing. You can see from here it's 14, goes to 16, and then it goes up to 18 here, and then up to this top part. Okay, this is an important feature because from this point on downwards, all of a sudden our y values start to decrease. So the y value here is going to be 20, but then as we move further to our right, we have a y value of 18, 16, 14, 12, 10, and then so on. It keeps going all the way down here. So where my pen is in red, that's where all my y values here, which represents height, is decreasing. They're all decreasing. So now the interval would be the domain, or it's going to be referring to all the values on my horizontal axis. In this case, the units will be in, that would be seconds. So at this point, when the y started to decrease, if I follow it all the way down here, it looks like that was at 1 second. So it goes from 1 second to, and they decrease all the way down to about this point, and I'm going to estimate this at about 2.1. So that's going to be 2.1 seconds. And if you're going to write this in interval notation, it's going to be 1 comma 2.1, and then I'm going to use brackets because we're going to include 1 second and 2.1 seconds in our interval. Question number 7 is going to be looking for the domain of this parabola here, and you could ignore probably this little image here. The domain, remember, is referring to our x values, and more specifically it wants to know all the x values that are included on this parabola. Now keep in mind, since we have an arrow here, this parabola keeps going down here to infinity. Negative infinity to be exact, and then this arrow keeps going on forever in this direction. So we want to figure out what is the lowest possible x value that we could have on this parabola. This x value here is 3, this is 1, this is 0, and then we're going to keep going lower and lower and lower for our x values. That continues on to negative infinity. And if we want to follow our x values to the right here, we're at x equals 3. Here we're at x equals 5, x equals 6, but we keep going on and on and on forever to positive infinity. And if we're going to write this in interval notation, we're going to use parentheses because parentheses are always used with the infinity symbol. You could also say all real values, or I'm sorry, all real numbers, because any real x value number will be found on this parabola. Now question number 8 is not just asking us to find the domain, it's asking us to explain it as well. So again, the domain is referring to x values. So my lowest possible x value on this, or actually, you know what, let's stop referring to it as x values. It's going to be the horizontal axis here, which is in time, or seconds. So really this is going to be seconds. So what's my lowest possible number of seconds in this situation? Well, you can't get any negative seconds, so right here this represents 0 seconds. So that's going to be my lowest number of seconds. Our highest number of seconds, we move all the way to the right, and we're going to cross the horizontal axis right here, which again represents time, just past 90. I'm going to guess that that's maybe about 93 seconds. So we go from 0 seconds to 93 seconds, and that's going to be my domain. And again, what does that exactly mean? Well, there's probably an object being thrown through the air here, which is modeled by this parabola, and that's how long it's going to be in the air for, because it starts up here at 0 seconds, somewhere between 2,000 and between 20,000 and 25,000. Question 9 is another question that deals with domain. It gives us a function and we have to graph it. Now, I went ahead and graphed this, but keep in mind that it's saying that a projectile is launched from ground level. The path of the projectile is modeled by this function. So it's a real world type of situation. So this is the graph. Will my graph continue on down this way past a height of 0? I don't think so. So I'm going to ignore my graph at this point. I'm just going to say that my last point is this blue point right here at 0, 0. I'm going to highlight there. Again, I'm just assuming this, connecting it to a real world situation. And then our object is going to go up in the air. It's going to increase, and then it's going to reach a maximum height here, and then it's going to decrease until y becomes 0, or actually in this case our vertical axis becomes 0. I'm going to highlight this point, and that happens at 8, 0. So back to my question, it says find the domain. Well, the domain is always referring to our x values, and in this case our x values are our p. So we want to figure out if this axis right here represents p, what is my lowest possible p value? And that's going to be 0. So we go from 0 to our highest possible p value is going to be right here at 8. Again, back to our real world situation, I'm going to assume that we don't have this part of the graph and it stops here. So our highest value for p is going to be 8. So if we want to write this in interval notation, we could go 0, 8, and then we use brackets because we want to include both of those p values on our graph. Question number 10 is looking at an interval, and it wants to figure out at what part of this interval are we increasing. So the interval is from x equals 0, so that's going to be x is replaced by time, so it starts there, and then it goes all the way up here through this parabola past the maximum height down here, and our x value is there. So between these two values of time, where are we increasing on our vertical axis here? So if you look at this part, all of our y values, or in this case our height is in feet, so our feet is increasing all the way up until this point right here. That's our maximum, and it's at this point that it turns, but we want to record the interval here. So from 0 to, follow this down, to 3, we write 0 to 3. That's going to be the interval where we're increasing. So if you want to write that in interval notation, it's going to be from 0 to 3. Now if we go back to our graph, we know from our maximum height here, we're going to start decreasing. So all of our values in height decrease until it hits the ground right here. From an x value, like we said here, of 3 to an x value of, or again in time, 6 seconds, that's when we're decreasing. So we could say from 3 to 6 seconds we're decreasing. And again in interval notation we'll go with 3, 6 with brackets because we include the value of 3 and the value of 6 in our interval. Our last part is asking for the time when the position was the most. So I'm assuming that's going to be our maximum value. So where did we have our maximum value? That was right here at 3 seconds. If you want to add some information, that that happens at 3 seconds, and our height is going to be 9 feet, which isn't required in this question, but just some extra valuable information we can pull from this situation. So to recap, we started with question number 6, and we wanted to figure out the interval where we were decreasing. Number 7 was looking for the domain. Number 8, we're explaining the meaning of the domain. Number 9, we found the domain for this real world situation. And number 10, we are looking at parts of this graph where it was increasing and decreasing, as well as the maximum value.